Hello. Alrighty, cool. All right, that was pretty fast. Excellent. All right, so now what we're going to do is we're going to spend a lot more time digging in depth into code and like what we use them for and all that kind of stuff. So let me go ahead and get our screen share started. So I actually remember to do it this time. And adjust all of my stuff so I can see what's going on. Okay, wonderful. All right. So let's look at, I don't know what I have. Let's look at these resources. I think we spent some time with them Friday, but let's take a look and then we'll look at some code. This is funny. Link to come. I don't care. Last in, first out. Yeah. Two with the plates. Wonderful. This I think is a really nice demo of like when we actually use this in real world examples. So this would be like writing a back thing for your browser. So we go through all these websites and then we go back. And so, you know, if you want to go all the way back to the first website you went to, you have to hit a bunch of buttons to get all the way back there. Cool. These are kind of weird, but I think they're kind of important to know. So like we care about using stacks instead of arrays because they can be a lot faster, especially if we know we're only going to be really messing with the end. Stacks can be a lot faster. And then they also take up less space, which again, not as important in JavaScript as in other languages, but the less space that your program takes up, the faster your website's going to be. So that's nice. We got some pseudocode. And then like, this is some really nice pseudocode. Like this is very like Englishy. Like you could hand this to anybody in any language and they'd be like, I got it. So we're creating a constructor. We're creating a count and we create an object to store everything in. We create a push method, a pop method, and then we return it. That's not bad. But yeah. The other thing that's really cool about this complexity, again, big O, this is one of the things that we care about with data structures and why we use different ones is because they all have different complexity, and it can be a trade-off. So like, maybe we do need to use something more complex because we care about like, you know, I'm trying to think when we would care more complexity about, you know, maybe we want something that we're willing to have something that's more complex because we need to have a specific thing. So like stacks, like all of those are one. It doesn't matter how big our stack is, our runtime is one, which is like phenomenal. But a stack doesn't always work because like what if I need it to be a queue or like I need it to be an array? So like we can't just use a stack for everything even though it'll be faster for a lot of cases. Yeah. Oh, also for a lot of times when we talk about stacks, we have a method called peek. And so our peek method for stacks is just look at what's on the very top thing, but don't take it out of the stack. So if you heard someone say peek at the stack, that's what they're saying is look at the top thing, but don't take it. Like if you're playing like a card game and you look at the top card, but you don't take it, you're just peeking. Peeking. It's two E's, not an A. An A is a mountain peak. All right. I think this is the code that I have. Yeah. So let's take a look. Again, this is on the probable happiness repo. So this doesn't necessarily like do anything. This is just all the setup for everything. Yeah, you still have to write code. So Venus S does it still pass through code? Yes, you still have to like write code in order to peak. You just don't like change the value of the stack. Cool. So here we have this prototype thing, which is really weird. It's just a different way of writing like functions that belong to a class or an object. We can just say like prototype it out. And this is a very odd kind of structure. I wouldn't stress about it too much. There are other ways to write this in here. But this is, if you don't like the class constructor method in JavaScript, you can do stuff like this. And this is maybe easier to understand. I don't think it is, but if like the class and constructor notation doesn't make any sense to you, this way might be easier to understand. So we created an object. Well, create a weird little function thing. Yeah, that's weird. That looks like Object-E. We can do that. And then we create a function for pushing and popping and size, and those all work exactly like they work for an array, which is cool. But obviously for a stack, we're not going to have anything like shift, unshift, or splice or anything like that because we can't do that kind of work. Very fancy. Cool. It goes through and talks about it. So you guys have that. There are a bunch of other ways to go into things. That's about where I want you guys to be though. I want you guys to have like a top level understanding of it, and when we go into like search algorithms, it'll make a little bit more sense. So that's just where I want you guys to be. So like if we wanted to do something with that, yeah. Give me this over here. So if we wanted to like make a stack, we could be like a bar stackable is a new stack, capital S, new stack, spelled correctly. I think that's all I want. And then I think this is right. And then we're going to say stackable dot push, and we'll give it, 10. And then stackable. I don't know why I keep wanting to say stabbable, but that probably says something about me. We'll add the number 15. And then we can console dot log stackable. And we can also console dot log stackable dot size. It might need that prototype thing, but I don't think so. Let's take a look. Oh, look at that. Okay, and then it says stackable size is a function. So it does give us our count though. And then as always, our stacks start with 0, not 1. Interesting. Interesting. Is this the better way to do it? No. But anyway, so we have our count and we have our stuff. So it behaves like an object in JavaScript, which is nice. And then we can just push things to the end of our object. You can put whatever you want here. I put numbers in here, but you can put strings. You can put whatever you want. I'm not sure why. Oh wait, is it because I'm supposed to do this? Did I just have a typo? Yes, I just had a typo. Excellent. All right. So it's a function. Well, yeah, it's a function. I was going to make an argument about it being a method, but I'll accept it as a function. So it needs to have its parentheses to make a function. So any questions about this piece? No? Okay, cool. Yep. So we can push and pop just like an array. They're really useful for when we need to talk through what? What piece do you want me to talk through? So the whole, all of it, or like just the one piece, or like which piece? The function. The size function? Okay, cool, cool, cool. Yeah, so originally when I did this, it gives us, oops, that'll break. So originally when I did this, oops, okay, I've got to CD back down into, oops. So originally when I ran it, so Stackable is a new implementation of our stack class or stack object. It's not necessarily a class because we didn't tell it to be a class. So it's an object. We're making a new instance of that object called Stackable, and anything that belongs to that stack object gets pop, push, and size. And so I pushed 10, 15 up here. And that worked. And then we console.logged the stack, and it gave us this. But I messed up on the size part, and I didn't tell it was a function. So all it was like, hey, that's a function. And so that's what it was telling me. And so then I have to tell it, oh yeah, you're right, that's a function. And so then when I ran it again, it actually ran the function instead of just saying, hey, that's a function, because I didn't put the parentheses right here. Because remember, JavaScript will try to do whatever you tell it to. So if you just be like, hey, console.log, this function definition, it'll be like, okay, here's a function, thanks. Just like when we forget to put like dot value or dot inner HTML on something and it gives us back the whole HTML element, that's what this piece did. It was like, it's a function. What do you want from me? So when we tell it to run the function, it'll do it. So is count the same thing as size? So size is a function that just tells us what the count is. That's all it's doing. Return this dot count. Yeah, so count is the value, size just gives us the value. So this one is a function and this is just the value that gets decided by how much times we push or pop. Zero and one are the order. Yep, 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 yep. Because it starts at zero and then increments and then goes. Yep, yep, yep. So our storage is our object. And then it's a bigger object that has a count too, which is nice. So it's an object within an object, which makes sense. So here's our stack object, this big guy. And then inside of that object, we have our storage object, which is like our actual values. So then if we went through and pop, and we just pop the last one. We don't have to tell it what to pop. And then we do this again. Oops. We get two things. So the first batch is this one. Oh, I'm sorry. Whoop, down here. So this is when we push all of our stuff and then we pop the last one. And then notice that it's taking that last one out. And then we could like pop again and we would have an empty one. And then we do have this nice little piece of code right here that if we try to pop when we don't have anything in the stack, it's just like, no, no, thank you, which is nice. Cool. Undefined. It returns undefined. It doesn't throw an error. It just says undefined. It's all good. Cool. All right, so did walking through that help a little bit more? Excellent. Excellent. Yeah, and honestly, like stacks, queues, and linked lists are very, very popular interview questions. So I would definitely spend time with these. I have all of these in here in the data structures one. Got our doubly linked to post. I don't think we finished going through all of this. That Atom Coder one is where I got all this code from. So if you guys want to flip through the rest of that, that's where a lot of that code came from. So the next thing I'm going to do something real fast. Yes. All right. The next thing that I want to talk about is there's a library in JavaScript called Q. Here we go. So this just like exists and you get to use it. Let me see if I can find the actual. Here we go. There's a bunch of different libraries for this data structure. So we have all of these things, and then you can just build it like this, which is nice. So this exists. I don't necessarily think like you like need it. You can handwrite all of this stuff yourself, and I think that gives you a lot better example of what's going on, so you can have a better understanding of how queues work. But just know that this does exist, so if you're like typing Queue.js and like you're looking for stuff, you might end up in the documentation for how this npm module works, not how the data structure works. So just be aware. You can use queue, you can use this library. If you need to use a queue, you can use it. It's pretty well documented, it's pretty popular. Just be aware if you're trying to like implement your own in your Googling stuff, you might end up on documentation for this piece, not how to do it. So just be aware of that. So this is not using the library, that's why it's called non-lib, because it's not a library version of it. And I will say, like we talked about, like stacks are crazy complicated to understand, but they're kind of weird. Queues make a lot of real world sense, and like the code doesn't look too bad. Like we created another one of these object, and it just has an array. That's it. And then we can add stuff, we can remove stuff. Yeah. You can get the first thing, the last thing, the size. Very fancy. I want to see. Yeah. And so because data is an array, we get to use all of our array methods. So queues are a lot easier to implement in JavaScript. They can be really useful. So let's go ahead and run this guy. Let's see what we get. I don't think, does anybody have questions about this code? I don't think this code is too, I think you guys, this is like totally on your level, but if we have questions, definitely ask. But like all these functions just return pieces of data, yeah? Or add stuff. It's not terrible, yeah? You guys can be like, yeah, that's terrible. I have no idea what you're talking about. Yeah, all right, so we got a yes, excellent. Yeah, so let's run it. Oops, wrong one. So down here, we've created a new queue using that kind of notation that we've seen before. We add some stuff, we remove the last one, we log it, and then we get the size, which is cool. Then we can also make a new one, and then this is the magic part. So we just name them two different things, and then we get a bunch of new stuff. I don't know what I have an empty console.log for. I guess I wanted a space. We're gonna remove that. That's weird. Cool. So we added 1, 2, and 3, and then we did a remove. So notice that the only thing that's left in our array is 3 and 2, because our first thing that we added is the first thing we take out, because it's a queue. You know, number 1 was first in line for our DMV thing, so it hangs out and waits, and then it gets to leave. And then also notice that it was 1, 2, 3, and then in our queue it's 3, 2, and then 1 would be here if we hadn't removed it. And then we just have like an array down here that just has 1 value in it. Any questions about queues? Nope. Yeah. Queues aren't too bad. They're very nice though for like when you know you need to manage positions. So like ticketing systems, orders, even just like digital representations of real world queues. So like let's say you need to do something like you only have so many agents to help run a chat. You can put everybody who's waiting in a queue, just like you would in like the real world. So yeah, I don't think these are terrible. This is all in here. I guess I won't add anything yet until we see what else I change. Cool. I don't have a code example for hash functions, because you can write whatever hash function you want. So I wanted to talk about first this nice picture, because I think this picture is nice. I had to change the background color to white because it defaulted to black. So here's just like a top level demo of like what it looks like. So you give it some input. Oh, for Q, could you start at 0? Yeah. So let me open that guy back up. The index is going to start at 0, just like an array, because it's an array. Its inherent structure under it is an array. And so everything starts at 0. We just put the value 1 in the first place. So the index was 0, but the value was 1. And so now the index here is 0, and the value is 3. Does that make sense? Yeah, awesome. All right. Cool. So this is like the top level of what this looks like. And now notice that this one says it's a cryptographic hash function. So hash functions by themselves are not inherently cryptographic. Because think about it. It can be anything. Like it can just be like literally like adding 1 is a totally valid hash function. But it's not very cryptographic. Like you can look at that and be like, oh, this plus 1. So if we're using a cryptographic hash function, we have a couple different flavors. We have SHA-1, SHA-3, I think is the other number, and that's SHA, and we'll talk about them. But our SHA hash functions are pretty popular. We have MD5, which doesn't get used as much anymore, but it does exist. And then we have other kinds of encryption algorithms like RSA encryption, like we talked about. The most important thing to notice with hash functions is that if you change the input a little bit, a good hash function will have absolutely no repeating things. So like when we talk about like the Enigma machine and all that, have I talked to you about like how people were able to figure out how the Enigma machine worked? Have we spent time talking about that? Yes or no? I don't remember anything. No? Okay. It's actually really cool because this is also how they decrypted the Zodiac Killer's letters. So all languages, so programming languages, but more specifically human languages, have frequencies. And so using frequencies, we can learn. Yeah, exactly. So Nick says they look for repeating words and letters. Exactly. So all languages have higher frequencies of certain letters than others. So in like English, it's like T, E's, S's, like those are all really high frequencies. So you can look at a coded example of a natural language if you know what the natural language is supposed to be, and you can do it's not hard, like you literally just count how many times the characters show up, and then you look and be like, oh, well, this, squiggly spooch showed up, the most. That one's probably an E. And then you can go through and use all of that information to figure out what the hashing function was. Or if it's just like, squiggles. Because like the Zodiac Killer didn't necessarily like do encryption. He just did like weird symbols. But yeah, so frequency analysis is how they got a lot of that stuff. And the other thing that's really interesting is when we talk, I'll spend a lot more time about this when we come back from spring break, but if the Enigma machine got cracked because they kept using the same starting code over and over again, if they would have followed proper security protocols and used unique keys for each transaction, there would have been absolutely no way to break it. So like, due to laziness is why the World War II went the way it did. It was just because they weren't following correct security protocols. So yeah, it's super cool. There's lots of YouTube videos and all that kind of stuff about it, but yeah. Why would no one break it until then? So if you use the same kind of key every single time, it's really it's a lot easier to understand what the pattern is. But if you use a unique key, sometimes called a one-time pad, every single transaction, even if you solve one transaction, you can't solve the next one. And that's the whole point of like one-time pads and that kind of stuff, is that even if you solve piece A, it doesn't matter because you can't get piece B. But if you use the same exact starting point for every single thing, once you find the starting point once, you can just translate everything else. So that's why it was like, once that pattern was found, it was easy to continue to break things. But yeah, it's super interesting. And we'll spend more time talking about it, and I'll probably like put way too many YouTube videos on for you guys, because like I think this is really cool. And I think it's like the fun part of the security stuff. It's like the puzzling part. A lot of people don't like this kind of math because it's confusing. But yeah, I think it's neat. Cool. So the whole point of that being that if you have a good cryptographic hash function, that when you change the input just a little bit, the resulting hash should be sometimes called a digest. I don't know why. I guess because it's been digested by the function, I think is what we're going with. It'll be completely unique, and you're not able to look at the results and understand what the underlying pattern is the whole goal. So notice that like the last 4 are pretty similar sentences. So like between 2 and 3, just a letter changes. But like these are totally different. If I gave you this piece right here and this piece right here, and that was it, it would be really hard for you to figure out what the relationship between them is, right? Excellent. Yeah. And bad cryptographic hash functions give you similar results if you give them similar input. So yeah, I just wanted to share this picture with you. We'll spend a lot more time talking in depth about this stuff because I think it's cool. But you don't necessarily like need to have like a really in-depth understanding about how these things work. Just know that like hash functions are how we do a lot of stuff. What does a cryptographic hash function look like? Yeah, let's take a look. So let's look at SH. Let's take a look. So SHA-256 is one that gets used a lot. We looked at this. Signatures are another thing that they're called. I want to look. We also use Bcrypt a lot. Can I see it? 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 Here we go. Okay, so this is what it looks like in code. So let's see if we can find the actual little math part that it does. So here's the hash computation. Let me zoom in a little bit. Okay, cool. So this part is the hash function. That's complicated. So we don't have to dive super deep into it, but let's take a look. So the first thing is just saying like, hey, I want to loop through all the letters in the original sentence. And then we're gonna make a new array. This kind of notation's weird. We don't typically use this kind of array notation. This array notation typically is because a developer is written in other languages, and so they're following the same standards. It does creating an array like this can be useful for, especially when we know we want it to be a specific size like this. But do remember that if you like mess up your notation, you can accidentally create an array with like 64 zeros in it instead of an array size of 64. Or you could like accidentally make an array with just the number 64 in it. So like, I don't recommend using this array notation. It can be really confusing. But yeah. And it also like doesn't do anything. So like all it's doing is like creating a higher chance that you're gonna mess something up. But when you do need to specify exactly what size, it can be useful. Alrighty. Prepare message schedule W. That's confusing. So we're doing another for loop that's nested inside our one loop. Basically, if our value is less than 16, we're going to parse it to a 2D array. That's confusion. If it's bigger than 16 and less than 64, we're going to implement this math. Oh, look at that. We got like a delta. I don't even know what that is. Is that omega? Confusing. All right, let's see if we can find where this is. The sum of 0 through. Let's see what else we got. I'm interested. All right, so these are, I want to know where this is. Where is this? I'm going to copy all this and open it in VS Code because I want to be able to navigate through this. There. Okay. So we have this class. This class is everything. I'm confused. Okay, let's actually read the comments because I'm confused. I didn't think this would be super crazy to go through, but I was wrong. So we have a message, which is the string to be encoded. We have some options. I don't care. We could format it to different things if we want to. We could determine what our output is. We're going to return the hash. Okay. Okay, cool. We also don't traditionally use the static keyword in JavaScript. That tends to be a holdover from like Java programming typically, but all that means is saying that this function doesn't change inherently, which is kind of weird. So it's like, I don't know if this metaphor is going to be helpful, but like a lot of functions are like a hand mixer, and you can take it and you can move it and you can do stuff with it. When we say that they're static, it's like saying it's a stand mixer. It's going to do the thing. It's not going to go anywhere. It's not going to change. It's just always going to be the thing. But like a hand mixer, like you can pull the little things out and put a different thing on it and use it in different places. But when we tell it static, it's like, it's just a stand mixer. That's all it can do. Don't move it. Okay, so this is the piece where we hand in the message. We give it some options if we want to. These are some initial hash values. Sometimes we call things salts. So you salt your hashes for security, which sounds very Waffle House-y. Which, by the way, some Waffle Houses are closing, which definitely makes me think it's the end of the world. Do you guys know Salty Boy? This is a little bit of a derailment, so I'm just going to write it down to talk about it later when we end. Waffle House index. Nick, are you saying it's good that Waffle House is closing? I'm offended. They're gross. Listen, I never said they were quality. All right, we'll talk more about the Waffle House index at the end. So what all these weird numbers are hex values that we're going to use to start our math with. And so like obviously if we were like implementing this for like cryptography, we wouldn't put our salt or beginning start values in the function. We'd implement them somewhere else and have it call them or something. Because obviously just having it in there is not great. But you know, we're not necessarily using this one for security. We're just using it for verification, probably. Sarah says, don't be ashamed of your unpopular opinion. You should be. All right, so then this is us going through our message and applying it to push it into arrays. That's where we get n, and then we encode each character. This is some of the math right here. That's weird. Oh, look at all those ors. Look at all those pipes. That's so weird. No, running off the end of message is okay because bitwise operations on not a number returns 0. That makes sense. Okay, that's weird. What is this thing right here? I am not 100% sure, but what I'm thinking it's doing is checking the result of that function and comparing it to that and making sure that it's less than that. It's what I think it's doing. This is some weird notation, my dudes. It might be, is this what I think it is? Pause as we digged a little bit too deep into some pretty complicated code. What I think, based on that note, I'm wondering if that's a bitwise operator. It is, okay. Okay, so then what exactly is this doing? We have not talked about this kind of math at all. Oh, okay, all right, that makes sense. So what this is doing is we want to have those 4 numbers for each thing, for each character in our original message. No, this one? Here it is, okay. For each of our character in our original message, we want to give it, I think 8 characters, I think is what it said. I don't remember. I think it said 4. What did it say? I don't know how to count. 4 characters, yeah. So what we're saying is because we know we want to give per thing, we want to give it 4 characters, so we end up with the correct number of bits at the end. All it's saying is that it's going to backfill it with zeros to make sure that we're in the correct length. Which is weird, and like we haven't talked about bitwise operators at all. Yeah. I didn't think we would be getting this deep. I thought it'd be like, yeah, look, here's this function. But yeah. Yeah, so basically there's a lot of complicated math and a bunch of different decisions and these things called bitwise operators going on. A bitwise operator means that we're doing math with like the ones and zeros that make up the data instead of doing it with the actual data itself. So that's what's up. I'll put this on the probable happiness thing so you guys have it. And then I'll put all these links in the syllabus too, so you guys have those. Yeah, and then notice that, again, these are signatures and that kind of stuff, so that way we know that we're looking at unique, or not unique, appropriate things. So like when we are checking our hash function, we know that we are getting the right thing that we're supposed to be getting. Yeah. The other thing to note, again, a hash inherently is not encryption. It's really hard to go back. There's no way to go back. And encryption has to be both ways because like yeah, sure. I mean, if you burn all your records, they're secure because nobody can read them, but you can't use them anymore. So yeah. Cool. So it was a little bit of a detour into some pretty complex code, but that's okay. So I'll put this in the syllabus. Just burn the bridges, just burn everything. Who cares? Burn it all. Records aren't real. Doesn't matter. But yeah. So I'll put all that in the syllabus so you guys have all that. This walks through it on a little bit more of like a picture level of how these things work. It also talks about like why we care. And this uses the ASCII thing like I was talking about. Like this is like exactly what I was talking about and couldn't think of numbers. So all of these strings, even though they're unique strings, because they're made up of the same letters, even though they're unique strings, because they're made up of all the same letters, if you just added them all up, like I was talking about, they would all equal the same thing, which is not a good storage thing, as we can see. Not a good time. So instead, we give it a different one. All this does is like multiply them together and then modulus them. And then everything gets unique values. So then we know exactly where everything is stored. So yeah, again, hashes aren't inherently encryption. They're a way for us to store data and like uniquely be able to access them again. Which is exciting. And this just goes through with some picture demos of like what everything looks like. And again, with like collision resolution, like even if you write like there's no such thing as like a perfect hashing function. But there's, you know, good ones and bad ones, but everything needs to have a collision resolution technique. A lot of times it's just, you just keep going. This one is just saying like, well, we'll just store them in the same bucket. It doesn't matter. We'll just put a link in there. That's one way of doing it. This way is nice because it's really fast because you don't have to reapply the function more than once for a collision. But it might not work if like you're not expecting things like, you know, if I want to like print everything in this table, I might not know that there's all this other stuff going on. And so like I might only print like this column and not even know about these guys over here. Go through it. I think this is written in C#. But yeah, then we can do a couple different things and it talks about when to do those and when not to. But yeah. Hash tables are like the biggest thing that we're going to use them for is like our database things. Like you won't be writing the math for this, but like this is how the like MySQL determines where things go. Is it has a hash function and it says, okay, you go here, which is cool. And then it also says that even JavaScript uses this kind of math in the background to implement objects, which is really cool. This gets in pretty deep about how like the fundamental structures of our programming languages work. But yeah. Cool. All right. I don't remember what Childlet stands for. Secure hash algorithm. Wonderful. I probably should have remembered what that one stood for, but I did not. Notice that there's a bunch of different standards. There's 0 through 3. Each one hops to be longer. And so I've said this a couple times, and I'm sure you've heard the joke of like, you know, you don't need to run faster than the bear, you just need to run faster than your friends. That's kind of the same thing with this kind of security ideology, is that we're making these standards that are more effort to break than whatever the data is we're storing. So like, you know, if it's something that's really valuable, like people's personal information, you really want to use something that's going to take a long time to break. Versus like if it's pretty low effort and you just want it to be like, please don't, you know, you can use something like that. Let's look at breaking times for encryption. So we talk about like what the time is to break things. Here's a picture of what it looks like. Wonderful. I want, this is not what I want. This is not what I want. This is not what I want at all. I will probably put this in your Slacker syllabus for you guys to have this. It's pretty cool. Talks about quantum computer again. I just wanted, that's not what I wanted. I am going to put that in your Slack for you though, because that was, is it? There's a chart somewhere that exists. That was weird. That says how long, here we go, this is it. All right. So if we have like a key with 128 bits, 1 billion years, that's a lot. So that's really, really secure because like, you know, that's a billion raised to the billion power. We're good. This is what we're at right now. It's technically breakable in, let's see, 100,000, million, billion, trillion, I don't even know what those are, years. So that's why we care right now. That's where we're at, is this AES one. But yeah. It's a Google? It's a Google? Are you kidding? Is that really what it is? I believe you, but I also totally would like, you know, be bamboozled by such pieces of information. But yeah, so this is what our most secure is. Just guessing. Oh, I believed you. You sounded confident. I believed you. Yeah. This is the thing that people are worried about with like quantum computing breaking, and I'll put that article in there for you guys so you can look at it a little bit more. But yeah, we'll talk more about other security things. I wonder if the table I'm looking for is in the syllabus. I hope it is, because it was a cool little table. But it just goes through and like talks about how long it takes to break into things. So like MD5 I think takes like a couple hours to break right now, which like, you know, it's just text messages that you don't really care about. That's fine, because a couple hours of work might not be worth whatever the payout is. But yeah, so I'll put both of these in the syllabus for you guys. I don't care about that. I'll put that in the syllabus for you guys. I'll put that there too, so you guys have all that. This one's in your syllabus already. You can flip through it. This is how to do a pretty simple one. I'll probably work through this and give you guys a good code example for this. But yeah, this is in your syllabus too to go through. Do you guys have that? Alrighty. So any questions about these things? I highly recommend in the Slack channel and in that education playlist that I made, there's videos about how to do the doubly linked lists. And when we come back from spring break, we will also go through and I will give you guys some like virtual whiteboarding thing. I haven't figured out exactly how I want to do it yet, but I'll figure something out. Cool. Any questions about data structures? Cool. Yep. I'd play with these. These are really good things to practice for interviews. Understanding how these work can give you a much better understanding of like how coding works and programming works. But again, like you're going to be a front-end developer, you might not need these, but understanding how these systems works can really, really help you write better code, no matter what position you end up in. Groovy. All right. So what I want to talk about next is like the actually, I'm going to go ahead and pause. Let's give our brains a second to percolate. I'm going to talk about something super dumb for like 30 seconds just so we can have some brain chill time before we hop into the next thing. So anyways, this is not a thing that I made up. There's this thing called a Waffle House index for FEMA. FEMA will like, this is a for real thing. FEMA will call Waffle Houses, and if Waffle Houses are closed, they know the emergency is more severe than they thought. So Waffle Houses are just like this fundamental key indicator. So like everything's good, we're good, you know, like limited menu, something's wrong. If it's restaurants closed, it's terrible. Things are bad. So like when Waffle Houses started closing during this like quarantine, I was like, oh, this is it. This is bad. What is there, a Walmart index? I don't know. They know the Waffle House thing is a thing, and I think it's because they just like are super about always being open. Yeah, now we know it's bad. Waffle House is closed. It's the end, man. Like, listen, everything else, like, it's the end of the world as we know it, hitting the Billboard top 100 again. Weird. But the Waffle House is closing. Go buy some water. Oh. But yeah, it's kind of like a joke, but like it's more of like we know like when the Waffle Houses reopen, it means that there's grocery stores and we know that like people are shopping and that kind of stuff. But yeah, it's cool. So like it's not like a real fact thing, but the Waffle House index is like a really interesting little measurement that people use. It's not formal, but it is just an interesting little measure to be like, yeah, they're just known for being open. Oh, look at this. Look at that. The 365 restaurants closed, but most of them are still open. Weird. There's a Big Mac index. Huh, weird. Okay, we're gonna go too deep. I just wanted to talk about the Waffle House index because we talked about waffles. This is after Hurricane Katrina. I don't think that Waffle House is open. The sign's still there though. Very weird. All right, cool. All right, so now that we had a couple seconds to let our brain percolate, I think other countries probably have similar things. Like, I'm pretty sure in like England it's gonna be Nando's, but you know, just like, it's just the thing. All right. Cool. Interesting. Jamila says no, Nando's is expensive. I guess. I don't know. I ate a lot of like Tesco sandwiches when I was overseas. That was like what I lived off of. That's the nice date. We go to Nando's for our nice dates. That's hilarious. Or any store in Australia. Yeah. That's funny. Nando's is like a nicer like fried chicken place. Like a fancy KFC, I guess. Like it's still like a fast food place, but like it has like nicer like quick service fried chicken based things. Yeah. It's super, super popular. Yeah, they make a lot of peri peri stuff. So like it's like, oh, what's that place off of Washington Road? I used to go there all the time. DeChico's. Yeah. Like it's somewhere between a KFC and DeChico's is what Nando's is. My favorite thing was Pret a Manger, which they have in America, just not here. Which is basically just like a Panera or a Starbucks. Pret a Manger is kind of bougie. What's the other coffee chain that's really popular over there? It starts with a C. They're like super bougie. I don't remember. I haven't been there. It's just by my house. You'd probably like it. They have a lot of vegetarian stuff. It's good. I enjoyed it a lot. And then it's in like the back of like a fancy like health food store. So, you know. Also, have I gone on my alkaline water rant? Okay, listen. I'm not here to like let anyone, you know, like live your best life. If you think that like water with a different pH is better for you, that's awesome. I don't agree or disagree with that. I don't think there's enough data. That's why I think Pret a Manger is and Nando's is fancy. Listen, Pret a Manger is bougie. I also have a joke about free bananas. Hydrogenated water is the best. Yeah. But like, so, you know, we got the pH scale, and if things are alkaline, that means they're more basic. Yeah, truck drivers overseas get paid more. I don't know why. I think it's because like the rest of the world is more afraid of driving than Americans. Americans don't care. We like, you know, like driving a lot. But like in other countries it's not as, I could see that. But yeah, okay, so pH scale, alkaline water, more basic, that's fine. If you think that that's better for you, that's great. I don't think there's enough studies to back it up either way, but if it makes you drink more water, can't be bad. But then people drink alkaline water and talk about how the pH being, you know, more basic is super good for you, which cool, fine. And then they put lemon juice in it. Lemon juice is an acid. You change in the pH with it. So you just said that like making this basic water is good for you, and then you made it into an acid. It'll make no sense. It'll make no sense. Like I am totally like, if it makes you drink more water, great, but don't tell me that like your alkaline water with lemon juice is better. Yeah, like if it makes you drink more water, that's awesome. Totally do it to them, but like please understand that adding an acid to a base makes it less basic. Water is water. You know, listen, I've been in Florida a lot and like I'm good. I don't want to drink Florida tap water. So like I don't necessarily agree with water is water, but it's just one of those things that like when people get all like, this is better, and then fail basic science stuff, I'm like, Yeah. All right, cool. So that was a couple minutes of derailment to let all of our data structures sink in. Yeah, Florida water's weird. I don't like all the sulfur. Like, it tastes like someone launched a bottle rocket into my cup. I don't enjoy it. Bottled water companies are plastic companies, okay? You're playing for the container and that's it. Okay, so we've had a couple minutes to talk about water and Waffle House to let our brains recharge from our data structures, as we've had a couple minutes to percolate. I don't mind some of the well water in Georgia. Some of my friends were on it, but like the one thing that like I always thought was weird is that like like almost everyone that I've known that's been on well water has like so many more cavities because there's no fluoride in the water. So yeah, I don't know, man. Sometimes being on city water is not bad. I mean, I will say I didn't have water last week for like most of Monday, which kind of sucked. But you know, something. Yeah, Nick says they keep the bottles. Yeah, you know, reuse them. Just be aware that like some of them have like BPA in it, and so you don't want to let the bottles get hot because it'll leach the chemicals into the water. Yeah, that's the reason I drink tap water when I'm in town. Yeah, get that fluoride on the teeth. But yeah. Yeah, man, I don't know. It's super weird. Okay, but now that we've had a couple minutes to percolate and let our brains relax and catch up, have we had any like latent thoughts about data structures we want to get through, or are we ready to keep on keeping on? Just want to let you know I'm still here. Yeah, it's all good. No, definitely. I want to hear people's opinions about stuff, especially when I kind of go off the rails. Okay, so the next thing that I want to talk about is search algorithms. Search algorithms, people hotly contest their what's the best search algorithm, and like you talk a lot about runtime and complexity, and like people write their own search algorithms to try to be like the fastest ones, and like it's a pretty hotly contested area. Magically, JavaScript implements a lot of these search algorithms for us, so we don't typically have to write our own, but I do want to talk about our two most popular search algorithms that we have. And you guys use these search algorithms all the time. We'll also talk about interpolation. That's just a mathy thing, so we'll talk about it, so don't stress about it too much. So our first thing is a linear search. So just kind of guessing from the words, what do we think a linear search is? In order, yeah, straightforward. Single line search, yep. So we have, you know, like you're at the grocery store and you're looking for a thing, you start on one end of the store and then you walk all the way through the store row by row by row until you find the thing you're looking for. So when do we think that would be good? And when do we think that would be bad? We have, Venus says IKEA and Sarah says my mom. Yep, 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 yep. So when do we think a linear search would be like a good search algorithm? Okay, we got stacks. Okay, maybe like if we know that we're gonna want like the most recent thing, we probably think a linear search would be better. Okay, what else? And I'll take like real world things too. When you're not sure if something exists, okay, I'm gonna put a pin in that, we'll come back to that one. How about like if we're know that like our list is already sorted, maybe finding errors, maybe. But like a linear search is really good when we know things are gonna be towards the beginning. So like if we alphabetize things and we know most of our stuff is going to be pretty early in the alphabet, a linear search is great. But like, what are some times that going through every single thing would be a bad way to search for things? Think about like worst case scenarios. when it's not ordered? Interesting. Okay. So why do we think a linear search would be bad if our data is not ordered? When things aren't stored in a linear list? Well, so even if, let's say things are alphabetical, what if I need a bunch of stuff at the end? Like, you know, my last name starts with an S, so that puts me pretty far down the line, you know? Or like, let's say a linear search is going to be bad if we know that like we want to search by like highest to lowest and like all the high values are really far away, then it'll take a lot more time. Yeah, so data could be like anywhere and it could take a long time. And I think that's starting to get to the point. Like a linear search is only really good if we know the stuff's going to be in the beginning. And that requires us to know what the data looks like. So it has to be sorted and we have to want the stuff towards the beginning, which like sometimes that's really good. Like if we're shopping and we want lowest to highest and we're almost always only going to shop for like the cheap things, that totally makes sense to use a linear search because the data is going to be ordered and we want stuff towards the beginning. Well, that's pretty specific, right? Like most of the time our stuff's unsorted and we don't really know what we want and like there's a bunch of other stuff going on. So linear searches can be really, really slow, especially with big sets of unsorted data. I do want to talk again about Sarah's point about like, if we're not sure something exists. If we're searching for something with a linear search, would that be a good thing? Or would we have to check every single thing in the set of data we're trying to get through to determine whether or not it exists? Yeah, you have to check everything. Yeah. And so linear searches can be really bad if you don't know what you're looking for. Yeah. So like if you are checking for something and you have to check every single object, it takes a really long time. So that's one search algorithm, and we'll look at code for all of these. Again, I'm just going to go through what all these guys are, and then that'll probably be it. Genuinely, we'll probably look at code tomorrow. I don't think we're going to go through all of these guys today because we only got like 25 minutes, right? Sure, that sounds right. So that's our linear search. I think that's our most easy to understand. We've done it, like, you know, you go through the library and you go through the last names of the authors. Like, we've all used the linear searches in our real life. Going through a list to find your names on a, like, attendance sheet, whatever. It's all there. A binary search sounds really scary at first until you realize you've been doing it since you were a little kid. So everybody remembers the game where, like, you know, just guess a number. What's the best way to play the like guess a number between 1 and 10? Ooh, Carlos guessed 5. Why? Explain 5. Let them pick the number before you select one. Okay, well, we'll assume we picked a number. Pick every number. Okay. So we got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So Carlos said pick 5. What's special about 5? It's in the middle. Yeah, so we get to get some more information, like is it higher or lower than 5? We get to reduce our search space by half. So like, let's say I'm gonna just like pick a number and be like her number 7. Okay, great. Your number 7. So if we say, okay, pick a number between 1 and 5, and we pick 5, and they're like, okay, it's higher, we get to reduce our search space by half. And that's why it's called a binary search, is because each search is going to be a decision that's going to be like yes or no, and we reduce our search space by half. So, okay, so then 1, 2, 3, 4, 5. So our middle one's 8. So then we guess 8. And then, you know, okay, they say lower. And then, you know, we either guess 6 or 7. But let's say for the sake of this, we guess 7 and then we're right. So that's what a binary search is at like its topmost level, is we're taking things and making decisions and reducing our search space. So that took us, so we guessed 5, and then we guessed 8, and then we guessed 7. That only took us 3 guesses. If we would have used a linear search, it would have taken us 8 guesses, because we would have been 0, 1, 2, 3, 4, 5, 6, 7. Yeah, fist bump to Carlos. Way to go, Carlos. But yeah, so that's what a binary search is at its top level, is we're going to ask questions and then break up our data according to that. You know, most of the time we talk about numbers, but like alphabetical, like we can think about that kind of value too. Fist bumps back, wonderful. But yeah, and so like that, our search, our decisions that we had to make went from 8 to 3. So that's a lot faster. And so that kind of search complexity can be like implemented, like if you have like thousands of things, using a binary search makes it a lot easier. Binary searches can be really slow for unsorted data. Well, actually, let me rephrase that. Our data has to be sorted for a binary search, right? If I had just 10 numbers that were any kind of number, we couldn't do this kind of math, right? So binary searches work really well for sorted data. But if you have unsorted data, you have to think about the cost of sorting your data before searching it. Kind of same thing with linear search, but like we can get away with unsorted data because we're going to just check every single thing. But for binary search, our numbers have to be sorted, or our data, because again, it could be like alphabetical. But yeah, so any any questions about these 2 top-level search algorithms? Okay, gotta know, yeah. Nick, you missed a lot. I don't know how long you've been gone. Tell them to wear shoes. But yeah, it's all recorded. And then you can always Slack me if you got questions. But yeah, cool. We'll look at code examples of this. Again, I have a bunch of code examples in that probable happiness thing that you guys can look at, but we'll spend time with it tomorrow. The next thing is kind of weird. We'll talk about what it means in JavaScript, but I want to talk about what it means in math first. So this goes back to like understanding that we need a little bit of statistical knowledge to do data analysis. And that data analysis can be a really useful skill no matter what position we end up in. Interpolation is when we're making decisions about incomplete data. So there's interpolation and extrapolation. So let's draw some pictures. I'm going to get some more colors. Just like real life. You know, and like the bottom's like bright orange. You think I wouldn't trip over it, but you know, here we are. So let's say we have a graph and like, let's say we want to figure out what is the like peak amount of time to study for a test. So on this axis, we'll have grades. We'll start at, you know, F, D, C, B, and A. And then over here, we'll have hours studied. We'll start with like 0, 1, 2, 3, 4. So, okay, we'll say the person who studied 0 hours got an F. And the person who studied 1 hour got a C, and then we know the person who studied 3 hours got a B, but then, you know, maybe like this person got like just a little bit higher B, and they studied. So in statistics, interpolation would mean that we could guess that the person who studies for 2 hours is probably going to get a B. We can make that guess. And the more data we have, the better of a guess we can make. So that's what interpolation is on like a statistical level. And this is something that you can do a lot of data with. Because like it's a function, you know? You can look at this and determine how many hours studied relates to grades. And it's just a guess, especially when we're talking about like anything involving humans. Like maybe the person who studied 2 hours still just doesn't understand what's going on and they get a D. Yeah, so Sarah says filling in the gaps, yeah. So that's what interpolation is. It's inside of stuff. Our extrapolation is more for when we have some pieces of data and want to make guesses about what's going to happen next. The biggest example of this is the weather. So we have a bunch of data about what the weather was before, you know, so like one day it was 70 degrees and sunny. And then, you know, like Tuesday, it was like 65 degrees and like partially cloudy. And so like, let's say the more data we have, the better results we can guess, but like Wednesday, maybe we can be like, I think it's gonna be 60 degrees and totally cloudy. And that's extrapolation. I don't know how to spell that word. Extrapolation? Extrapolation. You guys know I don't know how to write in English words. Extrapolation tends to be the more useful one that we do because we want to make decisions about what the future is going to look like. But which one do we think is more accurate? Interpolation or extrapolation? Yeah, interpolation is much more accurate than extrapolation. But we do a lot of extrapolation, especially with programming, because we want to know what's going to happen next. The more data that we have, the better decisions we can make. But yeah, so that's what it is at a statistical level, just so you guys have that in your brain. When we talk about interpolation in JavaScript, almost all the time we're talking about string interpolation. So string interpolation is already kind of what we've looked at. So this is what we talk about when we talk about it like this, because we're interpolating, we're putting data into a hole and guessing what should go there with a parameter. So that's why, like, they're called template, literally like any of those string template, literals, and like all of that, that's what interpolation is. And that's like where the math comes from behind it and why it works. But yeah. And also now I can say my favorite joke. There are two kinds of data, there are two kinds of people in the world. People who can make, who can extrapolate from incomplete data. I can tell you all sorts of bad jokes. There are 10 types of people in the world, people who understand binary. Sarah's only part of group 1. That's okay. That's okay. You can be a type 1. That's okay. It's also like my stupid binary joke. It's like there's only 10 types of people in the world, those who understand binary and who don't. That's okay. But yeah, cool. So we'll look at some code for this tomorrow. We're at a pretty good point. It's okay. When I misspoke, it probably was more confusing than not. So it is all good. Comedy is all about timing. Cool. So any questions about these two search algorithms? We'll look at some code tomorrow. We'll look at some other search algorithms. Are any questions about interpolation or template literals? I don't know why I want to call them template literals, but I do. Okay, so we got no. Okay. Does anybody have questions about what I'm expecting from you guys today and or this week? Yes. Okay, Nick, what is your question? What was it? What was what? I don't know what you're asking me, Nick. What do I expect from you? Or which piece? What do you expect? I expect you guys to work on your group project this week. Professional development, as always. Do I have a QA video? I can find you some. I don't have any particularly in my brain, but Stan, he's like T-Shine on Discord. He works at RSI. I don't know if he's a senior QA. I don't think he's a tech lead yet, but he's a really great resource for QA. So you can always message him on Discord. He's super nice, and he can give you a lot of QA tips because he's been doing it for 5 years. His real name's Stan Swinford, and then he's T-Shine like this on Discord, but his real name's Stan. So you can message him on Discord and all that. He's not part of our Slack. Guilt trip him into being a member. But yeah, he's a really great resource for QA. He's been doing it for years. So you can definitely message him for tips and pointers and all that. And then I will look and see if I can find some good QA videos for you guys. I'll put that on my list. Cool. All right. Okay, so Jamila asked about confused about backend description. Isn't it my job to create DB and also make it communicate with the other pages or question mark? So that is up to you guys, however you and your team want to break up the work. If you're in like a really big team, a database person might not even touch a backend person might not touch the database pieces at all. In your guys' case, I would probably have somebody do the database piece and then have other people do like the code connection piece. Or have one person do all of it and one person, you know, it's totally up to you. Especially since you guys don't have a dedicated like database person, your backend people will probably be doing both of those pieces. Okay, talk about it more at the meeting at 1. Excellente. Sarah, you shared the thing that you're doing all your project management with me, right? I know we talked about it, but I don't remember if I saw it or not. Yes? Okay, I will look again. You slacked it to me, right? I looked at it, right? Yes. I feel like I looked at it, but I don't remember it at all. I probably went, oh, that's cool, and kept walking. So yeah, please send that to me again. Then Jimmy says the president has now stated he extended the closure till April 13th. Good, 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 good. I'm glad that somebody talked some sense into him. That's good. So yeah, we will probably be remote the rest of the time, and then my best case scenario is that we will do our graduation like a week later and just do it at the beginning of May and we get to do it in person. That's my goal. That's my hope. That's what I'm working towards right now. I'll let you guys know if anything changes. Good positive news though, like China life is starting to return to normal. So, you know, there is an end and, you know, for the most part, people are okay. So hopefully with all the social distancing and all that, we can get there and, you know, we can get to the other side. There is a total happy ending to this, more or less. We'll get there. Yeah, don't let your guard down just yet. I'm just, you know, it's important to remain optimistic. If your contingency plan doesn't contain a morale piece, if you don't have a contingency plan, and our morale piece is hope. We're going to get through it. It's going to be okay. They don't share the demographics of people who've passed. Yeah. But, you know, I think as we watch like Italy go through their wave, we can probably get like a pretty good idea of what's going on. Yeah, I will say a lot of times in pandemics, people store a lot more information than they should because they don't want people to panic. So, you know, they might be doing it for that reason, or they might be doing it because, you know, they don't want to stress people out. Too late. Yes, people have panicked. But I think, you know, like, especially in America, there hasn't been a lot of particularly violent panic, which is shocking. Americans have been known to be totally bonkers off the wall. And this is just weird. Yeah, things are starting to look normal. So yeah, stay safe, keep washing your hands. You guys are all pretty smart, so I'm sure I don't have to tell you guys this. Yeah, Jamila, you have excellently transitioned to my point. House parties still count as socialization. Please don't go to house parties just because like you can't get like, you know, if you're like, oh, I'm a young healthy person, I'm not gonna die from it. Yeah, no. Somebody at my apartment complex was having like a total rager of a party on Saturday, and I was like, homies, no, what are you doing? But yeah, house parties still count as socialization. Please wash your hands. My neighbors had a party at the start of the quarantine. Yeah, and like, you know, I get it because like Saturday I went to the park, but like, you know, spending time outdoors in a low density, you know, should I just stay home? Probably, but like low density stress. This works better with the whiteboard behind you. Is it better like light balance? I'm not buying curtains then. Excellent. Awesome. All right, good to know. I'm not buying curtains then. I'll just use a whiteboard. But yeah, so just, you know, you guys are pretty smart. I know you're on top of it, but like, it just like, and like one of my friends is immunocompromised. I think she has MS, and her boyfriend's like, I want to go to a party. And they live together, and I'm just like, homie, no, you can't do this. Yeah, man, these people are crazy. So yeah, you know, stay safe. Yeah, like, no, I get it, because like the Friday night, like the weather was gorgeous. I was like, there are very few things that I want except for to be on that rooftop bar downtown. That is like what I wanted. But you know, we gotta take care of each other, man. All right, my rant's over. I'm gonna go up to the clubhouse so I can sign paperwork for Carlos. I have a meeting at 2. Is that all I have? I think that's it. So I should be available for most of the afternoon. I have that meeting. I think that's all I have today. So I should be pretty afternoon. The things after the pandemic: divorce, breakups, babies, and parties. Yeah. Yeah. See, I really, really want to know. Hugs, yes. Handshakes, roller derby. Yeah. So I'm a captain for my Hurley team. Haven't gotten to play in a while, and I just keep getting like antsy text messages like, I want to play. And I'm like, no. So yeah, definitely missing out on the sports. That's for sure. Like the weather's been gorgeous and I can't go play. That's okay. We'll get through it. Our practices were canceled in games. Yep. We had to make that decision too. Yep. Alrighty. Cool. So I'll be pretty available this afternoon. That's about all I got going on for you guys. Slack me if you have any questions. Code review on Wednesday as per usual, unless we've discussed a different day. Oh, Thursday's Pi Night. I totally dropped the ball telling you guys about Augusta Dev last week. Don't worry though, I stole that entire lecture and I'm gonna use it next week, or no, next week of class. So when we come back from spring break. So, but yeah, we'll be doing Pi Night virtually for, or I'm sorry, Python Data Sciences. It's not Pi Night. Whatever. If you guys want to join us for that virtual thing, 6 p.m. Thursday. It should be fun. But yeah. Hopefully we will get to do our ethics talk for Friday with Aubrey, which should be really fun. Cool. Alrighty. Other than that, Slack me if you have questions. I will see you guys tomorrow. Bye. I'm gonna need to bring actual pie. I agree. Well, we used to get pizza pie.